This time on Battle Factory, a combat suit for hiding in plain sight. A troop carrier with teeth that'll bite into any terrain. A pump truck that can shoot on the move. And a new take on a classic sidearm. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. To do his job and stay alive, a sniper needs to keep the target in range and stay out of sight. A sniper may position himself as far as 2 kilometers away from his target. And like a chameleon, he needs to blend into his background. And for that, he'll need a ghillie suit. The ghillie suit breaks down into the living layer, the burlap, and the smock. Ghillie suits are the ultimate camouflage, handcrafted by the sniper himself during training. It starts as a smock made from fine netting. The entire uniform is sprayed with an anti-reflective compound that reduces infrared signature to make it less detectable by night vision and thermal imaging scopes. The shoulders, arms, and chest area are softened so it looks less like a human form. The way to achieve this is with thousands of strands of material looped into the uniform's smock. Unraveled burlap looks natural and works best. The burlap is pulled apart by hand until there's enough thread to cover the suit. To match the foliage, some of the burlap is dyed. The multicolored strands are threaded into the netting to create uneven patterns. The burlap threads are tied to the mesh, covering the back, shoulders, arms, and chest. The softened silhouette will disappear into the background. Every sniper is an elite soldier, a sharpshooter in top physical and mental condition. During training, snipers spend over 100 hours of their own time hand-making their ghillie suit. It's part of their rite of passage. The same mesh burlap combination that covers the uniform is turned into a head-covering veil that hides the sniper's face and obscures the firearm. Ghillie, which means green man in Gaelic, was first invented by Scottish shepherds, hired by the landowners to protect their flocks from poachers. The Lovett Scouts, a Scottish Highland regiment formed by the British during the Boer War, were the first soldiers to use ghillie suits. And in 1916, became the British Army's first sniper unit. Once complete, the ghillie suit is distressed by dragging it through the dirt. Finally, the suit is sprayed with a fire retardant to make sure sparks from the rifle don't ignite the flammable burlap fibers. In the field, the sniper collects local vegetation, fastening bits of twigs, leaves, and grass to form a suit that's a perfect match for the surroundings. In every sniper force in the world, ghillie suits are as much a part of the sharpshooter's kit as his rifle. Coming up on Battle Factory, a tough transport vehicle with a customized weapon system. And a fire truck for when the blaze goes beyond the city limits. When these ballistic steel plates are cut and shaped and welded together, they'll make the body of an armored personnel carrier that's built to be fast and flexible. The CV90 is the next best thing to a battle tank, but faster and more maneuverable. It can be fitted with or without a turret, with weapon options that include machine guns, cannons, and grenade launchers. The CV90 is the Swiss Army knife of heavy artillery. It can be customized to suit the mission. In 2007, in Afghanistan, the CV90 first saw action during Operation Harakati Yolo, a ground offensive to oust Taliban militants from northern Afghanistan. The CV90, carrying a Norwegian battalion, took heavy insurgent fire. In a high-speed chase over hostile terrain, it outran the enemy, then returned fire with machine guns and cannon rounds until the CV90s were able to beat back the Taliban and get the troops safely home. The CV90 Armadillo breaks down into the turret and the tank body. The CV90's armor plating starts out as laser-cut sheets of bulletproof metal. The automated beam also carves out holes for sights, cables, and weapon stations. Then, the precision-cut sheets are bent into shape under 1,800 tons of pressure. And now, all the pieces have to be assembled. The first step is to temporarily weld the pieces together. The body is hoisted onto a robotic welder that automatically performs thousands of accurate welds. The same job would take a team of human welders weeks to accomplish. But after a full day on the automated welder, this job is complete. Flaws in the welds aren't usually visible to the naked eye. The only way to find them is with an X-ray machine. There are critical spots on the CV90 that will take the brunt of the weight when it's deployed. When the 35,000 kilo CV90 hits a bump in the road at 70 clicks an hour, even a hairline fracture could put the whole frame out of whack. At the measuring station, techs use lasers and handheld probes to make sure that every surface and angle is accurate. The probe can tell if it's off by more than 0.05 of a millimeter, and if it doesn't line up with the other components of the vehicle, it won't be able to accommodate the modular weapon system. This particular CV90 will be armed with a dual grenade launcher. Construction begins with the turret mounts. The turret is cut, bent, and welded using the same construction techniques that built the CV90 body. This same turret can be customized with multiple weapon configurations, from as small as a .50 caliber machine gun, all the way up to a full-sized battle tank cannon. Wiring and cables will connect the turret to computer controls. If everything functions perfectly, the turret will be secured to the CV90 body. Before the CV90 sees active duty, it has to pass the test track. Running at 60 kilometers per hour, speed bumps are designed to rattle the frame, and then it's sent into the field to push the vehicle to its limits. This one tackles the terrain without breaking a sweat. The CV90's options may change with the mission, but the objective is always the same: make it back alive. Coming up on Battle Factory, the fire truck you need when you have to take your water with you, and a .45 semi-automatic that's a century in the making. When this aluminum tank is finished, it'll hold 3,700 liters. That's enough water for a small swimming pool, or to put out a good-sized blaze. And it'll be sitting on the back of a mobile fire truck. Because when you can't connect to a hydrant or pumping station, you've got to take your water with you. In times of war, firefighters can't rely on conventional water supplies. During the London Blitz, thousands of camouflage water tanks were hidden throughout the city, and pumps were installed under the bridge to siphon water out of the Thames. In peacetime, the mobile fire truck is often dispatched to handle wildfires. And in war, it's often sent to places with no access to water. The Grizzly Pumper Fire Rescue Truck breaks down into the water tank and the pump house. The pump house is the heart and brains of the fire truck. Gauges and wires are housed in an aluminum cabinet, which sits in the middle of the truck body and controls the pressure of the water jets. The pump house is fitted with pressure gauges and the wiring system that controls the power and temperature of the water jets, so the water doesn't freeze even at 40 below. The pump house cabinet is made up of 77-kilo sheets of marine-grade aluminum, which are fed into a hydraulic guillotine shear with 78 kilopascals of pressure that slice through the 5mm sheets. Then, the aluminum is bent into shape using a press brake. The cabinet is attached, and the pump house is complete. On this fire engine, the pump house is connected to the vehicle's main drivetrain, which powers a pump working at 4,700 liters per minute, or 5 times the pressure of an average garden hose. This pump and roll capability means the truck can spray water on the move. During the Bosnian War, fire trucks equipped with onboard water tanks fought the flames during the siege of Sarajevo. The subframe is made from high-strength aluminum, tough enough to hold the 3,700-liter tank. The subframe is cut and fused using metal inert gas welding. It keeps out impurities and strengthens the bonds. Then, the side cabinets are cut, shaped, and welded. The aluminum surface is buffed with the center to prime it for painting. The subframe is then added to the side cabinets, forming the enclosure that'll hold the water tank. It's got a 14,000-kilo maximum capacity, so it can easily support the tank, which weighs about 4,000 kilos when full. The fire engine starts its life as a stock cab and chassis. Once the truck bed is ready, the pump house is lowered onto the chassis. Instead of transferring the heavyweight rear cabinet and subframe to the truck bed, it's hoisted over the shop floor so the truck can get underneath it while it's lowered onto the frame. Then, the tank is dropped in. The pump house is connected and wired to the truck's computer. This controls the water flow and makes sure the pressure doesn't get dangerously high. A remote-controlled nozzle is mounted on the front bumper, which can pump out a constant 250 pounds of water pressure per square inch. That's about 500 times what comes out of your kitchen faucet. The seats installed in the truck's cab include built-in oxygen tanks, so when the firefighter mounts up, he can slip right into his air supply. For additional O2, extra tank holders are bolted to the cab exterior. The ladder is slid into a side compartment. Lights are installed. Now, this fire engine is ready to battle any blaze. No matter where the call, the Grizzly Pumper Rescue Fire Engine can bring the fight to the fire. Coming up on Battle Factory, the military's most enduring sidearm aims high. This block of steel will be transformed by innovation and artistry into the ultimate update of an American classic. An iconic sidearm and a formidable weapon. The 1911 semi-automatic handgun was invented over a century ago by second-generation gunsmith John Moses Browning, one of the fathers of modern firearms. The 1911 did tours of duty in both World Wars and Vietnam, and is still prized today by collectors and enthusiasts. The design has changed very little in the last 100 years. The 1911 breaks down into the slide and the frame. The frame of the Cabot 1911 is carved out of a high-purity block of steel with a water jet cutter. Water mixed with sand can slice through the thick steel with ease. What comes out of the water already resembles the 1911 signature profile. Once it's been cut, the body is machined on a CNC, or computer numerical controlled router. Water and lubricant flood the machining compartment to cool the metal and reduce friction, while the body details are tooled and holes are drilled to exacting specs of a 0.025 millimeter tolerance. The pistol body is again submerged in water, this time to conduct electricity. With both the metal and water electrically charged, intricate detailing is done using an EDM, or electric discharging machine. Stainless steel wire is charged with an electric current at 300 volts, then run through the magwell, carving the fine details onto the steel surface by literally burning off metal particles. The 1911 is now ready for engraving. The body is placed in a jig, a device that holds the gun steady for engraving. Using a cutter, the engraver etches out a serial number and the company details, so that every 1911 can be traced back to the day it was made. The slide of the gun is cut using the same water jet cutting method as the body. The spring-loaded slide of a handgun is pulled back to cock the hammer, then grabs the cartridge and pushes it into the chamber of the barrel on its way back. After it's cut, the slide is placed on a grinder and shaped to perfection so that it'll marry perfectly with the body. The measurement is so exact, it's the equivalent of splitting hairs 30 times over. Using a surface grinder and drawing on years of muscle memory, the final filing is done by an experienced hand, smoothing out the surface. What makes this gun special is that it's constructed to fit together perfectly without any adjustments or alterations. Called clone technology, The frame and slide are probed inside and out with a coordinate measurement machine to make sure they conform to exacting measurements. The measurement room has to be exactly 20 degrees Celsius. Plus or minus 1 degree can cause the steel to expand or contract. Finally, the gun is treated and assembled. Since its creation in 1911, the semi-automatic pistol has been an icon and the stuff of legend. But the most incredible 1911 story comes from World War II, when Lieutenant Owen J. Baggett's plane was shot out of the sky over India. He bailed out, only to become a floating target. A Japanese Zero fighter plane was headed straight for him, machine guns drawn. At the last moment, Baggett raised his holstered 1911 and fired 4 shots into the cockpit. The Zero went into a nosedive. One man took on the most notorious Japanese fighter in the sky with nothing but his 1911 sidearm, and he won. For over a century and through countless battles, the 1911 has been locked, loaded, and ready for action.